Still on complex number, we'll be discussing first the polar representation of a complex number. Then second, we'll be talking about argument of complex number. Then thirdly, we'll be talking about the De Moivre's theorem. Now, in our previous class, we have that I, which is part of the element that makes a number a complex number, is equal to the square root of 1 minus 1. And with this, it implies that when you square both sides, we have that what? I squared equals what? Minus 1. Now, we have different kind of examples of a complex number. You can say z equals to minus 2i. Z equals to 3 plus 2i. Z to be equals to minus 4 minus I. These are examples of complex numbers. The 2 here is the imaginary part. The minus 2 here is the imaginary part of this complex number. 3 here is the real part of this complex number. And 2 here is the imaginary part of the complex number. Same thing here. So the coefficient of I here is minus 1. So which is the imaginary part of the complex number. And remember this can also be written as z equals to minus 2i. This is the same thing as 0 minus what? 2i. So which gives us the real part to be what? 0 and the imaginary part to be what? Minus 2. Now, we want to talk about the polar representation of this complex number. This complex number here, this form of representation is the Cartesian representation, okay, in the xy plane. Now we want to represent it in the polar form where we have r theta. Now, so we have let z to be equal to what? X plus iy. So this is the Cartesian form. Now, our aim is to represent this Cartesian representation in polar form. So, and to represent this, we need to find theta, and also we need to find r, which is the modulus of the complex number. Now, representing this in the graph, we have that here, this is the x-axis, and here is the what? Y-axis. Now, representing complex number in a plane, we have it as x, y, because complex number can be written as a pair. Now, if this is the point x, y, then we have a distance from the origin up to this point. Now, if we say here is O, and here is our P, then this is our x-axis. I mean, this is our y-axis, and this is our what? X-axis. And this line is making angle 90 with what? The x-axis. And also this line OP is making an angle theta with the x-axis. So our aim now is to represent this Cartesian form in polar form. So we need theta and we need this side. And this side from our previous class is noted to be the modulus of the complex number r. And it is given by what? R equal to what? The square root of x squared plus what? Y squared. This is the modulus of the complex number. Taking note of this z equals to x plus iy. Now we need to find x and we need to find y. Now by so doing, we have that denoting this as capital. So considering angle considering triangle POX, we have that, look, this is now opposite over what? This is opposite over adjacent, and this is adjacent over what? Hypotenuse, right? Now, our unknown here is x and y, but we have our r already. So we'll use r to find our x, and we'll use r to find our y. So we're considering this side and this side. So this is adjacent over what? Hypotenuse. So we have, that is cos, right? Cos theta to be equal to x over what? R. So cross multiplying, we have that x is equal to what? R cos what? Theta. That's good. Now, for y, so consider this side on R, right? So we have that sin theta to be equal to y divided by what? R. So we have y by what? R. So which implies that cross multiplying, we have that our y is equal to what? R sin theta. So we have our x to be r cos theta. We have our y to be what? R sin theta. So this time around, we will substitute the value of x and y in this Cartesian form. So by so doing, we have that the Cartesian form is x plus what? Iy. Now, in further form now, we have t to be equal to, our x is what? R cos theta plus this I r what? Sin theta. Now, you can now see that r is coming, which is the modulus of the complex number. So we have r open bracket cos theta plus what? I sin theta. So this gives us the polar representation of the complex number. So is that clear now? So let's get this done quickly. Then we will have one or two problems and solve them. We can get the polar representation. Next, we will need to find the argument of a complex number. And from the Cartesian form, you can see that line OP, which the complex number x, y makes an angle theta with the x-axis. So that angle theta is actually what is called the argument of the complex number. Okay? So, and which is written as theta equals to argument z. You will see this way, which is the argument of a complex number. So our aim is now to find theta. And finding theta, we have many forms to do that. If you know your modulus of the complex number and you know your x-axis, you are okay. You can use x, y, and z to find it, so whichever values that you have. So theta is also r which is equal to, now considering x and y, considering x and y, you will see that this is the adjacent and this is the what? Opposite. So we will now use tan theta, right? So which is tan theta to be equal to what? Y over what? X. So theta, so to find theta now we'll take the tan inverse of both, right? So tan inverse of tan theta is equal to tan inverse of what? Y over what? X. So when we do that, we're left with theta, which is equal to what? Tan inverse of y over x. So this will give us the argument of a complex number. And if you check, considering is c equals to x plus iy, we have that x is the real part of the complex number c, and the y is equal to what? The imaginary part of the complex number c. Okay, know the argument of the complex number and you are able to represent the complex number in polar form. So we will have 2-3 examples that will give us on how to represent the complex number in polar form. Example 1. Express we have 2 plus 2 plus 3i b minus 5 plus 5i c minus the square root of 6 minus root 2i and d we have minus 3i. So here, for the first part, this is the complex number 2 plus 2 root 3i, and this is in Cartesian form, right? Yeah. So our aim is to represent this in polar form. So what we need to do is that in polar form, we have z to be equal to r, which is the modulus of the complex number, right? Then cos theta plus what? I sin theta. So this is what we are asked to represent this in this form. Yeah. So here we need to find our theta and we need to find the modulus, right? Good. So considering this complex number, our x is what? 2, right? Then our y is what?
Y is 3.
2 root 3. 2 root 3, right? So now the modulus of the complex number z is equal to r, which is the same thing as the square root of what? X squared plus what? Y squared. So our x squared is what? 2 squared plus 2 root 3 squared. So you take the square root. 2 3i. Yes, the y is just the coefficient of I. So, which is what? 4 plus what?
R is 4.
Or 12, right?
Yes.
And which is the square root of what? 16. Which is what? 4. So our R is 4. Now, the next thing now is to find our what? Theta. Now, we have our R to be 4. We have our x to be equal to 2, and we have our y to be 2 root 3. So we can use any of the sides now to find. But if we want to use the time inverse method, we will have that our theta, which is the argument of the complex number, is given to be time inverse of what? Y over x. Which is the same as tan inverse of 2 root 3 over what? 2 root 3 over what? 2 cancel 2, so we have tan inverse to be what? The square root of what? 3. Which is equal to what? 60 degrees. This is in degrees, so in radians. Which is pi over 3. So in radian, our theta is pi over 3. Now, so what you need to do now is
how you reach pi over 3 in radian.
pi is the same thing as what? 180 degrees, right?
Yes.
Pi in radian is equal to 180 degrees. So to convert this 60 degree now to radians now, so you divide this by what? 3. Divide this by 3. Because 1/80 divided by 2 is what? 60. So the equivalent of 60 degree in radian now will be pi over 3. Do you understand this? So our theta now, which is the argument of the complex number, is pi over 3. So what we need to do now is we can simply sketch this. Now this is our Cartesian plane. Now we have 60 degree, right? So here, somewhere here, we will have your angle here. Here is what? 60 degree, right? Good. X is 2. So here is 2. R, which is the modulus, is 4. Then here is the complex itself, which is 2 plus 2 root 3. 2 root 3. So here is x axis and here is y axis. So this is the representation. So now in polar form, so you have your theta and your r. So in polar form, Z, which is the same as 2 plus 2 root 3. 2 root 3i is the same thing as what's your r? 4 cos 60. So we prefer to use pi over 3. Yeah, cos 60 degree, the same thing plus what? I sine 60 degree, right? So which you can written as 4 cos pi over what? 3 plus I sin pi over what? 3. So this is your final answer in polar form. Is that clear? Yes. Good. Now for the B part, we have minus 5 plus 5i, which is equal to what? Z. This is the Cartesian form, right? So now we need to find the modulus and the argument of the complex number. So by so doing, what is the number of x here?
Minus 5.
Minus 5. And where's our y? 5. So here we have that the modulus, which is equal to r, right? Is equal to what? The square root of minus 5 squared plus what?
5 squared.
Plus what? 5 squared. So there we have minus 5 squared is what?
25.
So our r is 25 plus 5 squared is what? 25 square root. That is the square root of what? In singular form is what? 5 root. Good. So this is the modulus of the complex number. Now the argument of the complex number theta is equal to tan inverse of y over x. What is our y?
Y is minus 5.
Is that?
Minus 5.
No, y is 5. Right? Tan inverse is what? 5 over what? Minus 5. That is minus 1. So theta is equal to tan inverse of what? Minus 1, which is equal to what? If tan inverse of 1 is 45, so tan inverse of minus 1 is minus 45.
Yes. Yes. You can do it.
Then on the
It is actually. So can we subtract it from
the second quadrant.
Yeah, it's going to be on the second quadrant now. So 180 minus 45.
But that is negative in the second quadrant. That's 180 minus 45. No, so 180 plus
180
minus
plus 180 plus minus 45. This is what we have.
yes.
So what is going to happen now is our theta now will be 180 degree plus the value of the angle that we have. So which is 180 minus 45, which is equal to what? 135 degree. So because 45 degree the first quadrant is 135 for the second quadrant. You get it now?
negative in the second
Yes, the value of theta.
Use the other side.
Yes. And to testify to this, we can check by representing this complex number in the cartesian form. And look at this. What is our x-axis, which is minus 5, right? So here's what? Minus 5, right? And our y is 5. So here is what? 5. So what it means now is we are going to have something like this. Do you understand? So this is the theta that we have.
It's very strong. That's all it is inside.
So this is minus 5 plus 5i. That clear? It's moving, right?
Yes.
So this is minus 5 plus 5i. Now, so here is 5. Now, from our calculation, here is what? 5 is what? And remember, so this is the starting of the answer. So from here, so which is the 135? And here is what? 45. Do you understand? So this is what we have. So now, converting 135 degree to radian now, so you have what? Pi is 180, right? Good. So, let's say, what is, then what value will give us 135, right? So, we have this equal to 180.
135 times 2.
Is that?
135 times 2 over 7.
135
Times 2 over 7.
times 32 over 7. We don't need to compare this to. We want the answer in pi.
Okay, part.
We want the answer in pi. So what we'll do is we divide 180. We divide this by just a matter of cross multiply.
135 pi over 180.
135 pi over 180. How many 45 can go inside 135?
25?
Yes.
3 times.
3 times. So we have 3 pi
3 over 4 pi.
over how many? 45. So this 135 is 3 pi over 4. Right? So when you have this now, so in our polar form of z equals to minus 5 plus 5i is the same thing as what is our r? 5 plus 7. So we have 5 plus 2 into
cos 3 over 4 pi.
cos 3 pi over 4 plus what?
I sine
I
3
sine
pi over 4.
3 pi over 4. So you get this now.
Yeah.
So this is the polar form of this complex number t equals to minus 5 plus 5 pi. So we move to this step. So we check on this and this. We have minus the square root of 6 minus minus the square root of 2i. This is our complex number Z. Now, we need to find our modulus and our theta. And the modulus, which is Z, is equal to what? R, which is the square root of x squared plus what? Y squared. Right? So we have, what is our x here? Minus root 6. So we have minus root 6 square plus, what is our y? Minus root 2 square. Then you take the square. You get it now? Don't, excuse me. So which is minus root 6 square plus minus root 2 square, right? So we have here we have r will be equal to 6 plus what? 2 plus 2. That is the square root of 6 plus what? 2. 6 plus 2 is what? 8. So the square root of 8, which is what? 2 root 2. So this is our modulus. So we need to find the theta now. Theta, which is tan inverse of what? Y over x. What is our y? Tan inverse of minus root 2 over what? Minus root 6. So we have tan inverse of minus dash minus, right? So root 2 over what? Root 6. Rationalize. So we have tan inverse of root 2 times root 6 over what? 6. Right? By rationalizing the denominator. Good. Tan inverse of what? Root 12 over 6. That's 2 root 3, right? Tan inverse of 2 root 3 over what? 6.
That is root 3 over 6. 2 over 3. 2 over 3. 2 over 3.
So we have our theta tan inverse of what?
2 over 3.
In standard form, tan inverse of 3 over 3.
No, root 3 is 60.
Root 3 is 60. Then this is 1 over root 3, which is 30. Because this one, root 3 over 3 is the same thing as 1 over root 3. When you rationalize, you have 1 over root 3 times root 3 over what? Root 3. Which is what? Root 3 over what? 3. So 1 over root 3 is the same thing as root 3 over 3. Okay. So if tan inverse of root 3 is 60, then tan inverse of 1 over root 3 is 30. So here is what? 30 degree.
Alright.
Now, representing this complex number in the plane, so you have this. We have that. Look at it. This is minus root 6, which is your x, right? So here is minus root 6, and this is minus root 2. So here is minus root 2. So we have this is the origin, right? So this is minus root 2, and this is minus root 6.
Like,
So this angle here is what? 10 degrees. So starting from the origin now, this is 90, 180 plus that is what?
210.
210.
Yes.
So our theta is equal to what? 210 degrees. Okay? So now, knowing that your theta is 210 degrees, then in polar form, T, which is equal to minus root 6 minus root 2I, you understand? Then is equal to, what's our half? 2 root what?
I already told you it's 5.
2 root,
5, 5, 2.
no, 2 root 2.
It's 2 roots.
Oh, sorry.
2 root 2. Open bracket cos 210 plus what?
I said
Plus I times 210.
Plus I times 210. Then you can convert the
210 to 5.
210 to radian.
That's one.
Pi 7, 7.6.
7 pi over 6. So here we have in radian form, we have Z equal to Z to be equal to 2 root 2 open bracket cos 7 pi over 6 plus I sin 7 pi over 6. So this is the polar representation of this complex number. Is that clear now? Good. So we are left with what? Minus 3i. So we're going to do this minus 3i yourself and see what you come up with. Then we will now continue with the theorem. Yes, you have to do it now.